thanks a lot for coming. I've worked at Microsoft for 8 years, and for the first 4 years when I worked at Microsoft, I was a lot like the rest of the Microsoft employees back in those days, where I worked on developing new features for our software, but I didn't really know a lot about engineering security into those features. So 4 years ago, something changed. The first thing that changed is that Microsoft, Bill Gates, and everyone else decided that Microsoft was going to try to do security. And you've seen evidence of that today through a series of talks, and I appreciate you coming to mine. And the second thing is that my brother discovered that he could download music for free on the internet, which meant that over the last 4 years I've been cleaning up the systems around the family house, and I'm sure that a lot of folks can relate to that experience as well. So based on those first 4 years and the second 4 years and the changes therein, that's kind of a framework that we're going to use to talk about security at Microsoft today. We're going to talk about a mock attack. Think of it as a crime scene recreation of an attack that might have taken place before Windows XP SP2, kind of before some of the SDL practices that we've designed. And then we're going to look at how the SDL has changed the way that Microsoft thinks about security and the way that we engineer our products. And we'll look at the specific changes that that's evoked, specifically in IE7 we're going to focus on. There's a meta theme that I want you to pick up on in terms of the changes that we've implemented for IE7. We've made changes that help protect the system, that help the system be more robust against attack. And we're also making changes that help the end user make better decisions about the things that they do on the web. So it's worth starting, again, from back in the old days of Microsoft. And I worked on the IE6 team. And I was the program manager for a feature called the media bar, amongst others. But the media bar allowed you to play music directly inside of the browser. And in addition to that, we made it scriptable so that a website could target content at the media bar and get some information about the content that, what state was the song in terms of how it was playing. And I remember one of the first memories for me with security was, as we were designing and building that feature, I thought, hey, is it possible that maybe a website could get some information about the media that you're listening to, but it's not the website that started that media in the first place? And maybe it's some content that you don't want that website to know about. And I didn't even understand that that was really a security bug, but I knew there was something wrong there. And I remember that in the old Microsoft, it was difficult for us to go and have a conversation about fixing that type of a bug and explain why it was important to put security first. As a result, when we shipped that feature, we were able to fix that bug, but there were some other bugs that came out that were security bugs that we might have picked up on had we been focused on security development from the beginning. So really what we're going to do now is I'm going to go look at, again, a crime scene recreation. Here I've got IE6, and I'm going to try and recreate something like that media bar attack. Now nothing I'm going to show you here in terms of these attacks is real and something that an attacker could do today, but it's interesting because it kind of demonstrates some of the theories and attacks that people used to use. So here, this page is on myevilmyspace.com, and what it's done is it's created an iframe through to a local resource. That local resource is on my local machine. IE6, before XPSP2, had elevated privilege for HTML that was running inside of the local machine. So if myevilmyspace.com could inject some HTML into that local resource, well, myevilmyspace.com could do some bad things on my system. Well, here I can see that IE threw a script error, and what happened is that myevilmyspace.com's domain name didn't match the domain name of the local resource, and therefore that failed. This is an illustration of the cross-domain security boundary in IE that's always been there. But so this part of my demo didn't work. But historically, in previous versions of IE, there were holes in that boundary. For example, imagine that in that domain name, I encoded special characters, and I used percent signs to try and encode the actual same path of my local machine into the address bar. And you can imagine that IE might make a parsing error and mistake the URL that's in the address bar for the local system. And then that script injection might be successful. So I can't pull that off today, but what I'll do is I'll go over to another local resource, Now here, it's the exact same file. I've just navigated to it directly on my IIS system. But now it's going to be able to go ahead and inject that into the local resource. Okay, so something bad happened. Who knows what's going on here? Windows Defender's coming up. Something really nasty happened. Let's see what's going on. I go over to my startup folder. Uh-oh. Okay. So what happened is I was able to inject some script that accessed an object that was unsafe for use, and then use that object to download and ram evil.exe into the user startup folder. So the next time the end user boots up their system, evil.exe is going to run on this system. Now, again, this is a crime scene recreation. I had to go find an old vulnerable object that's been patched for years. I had to uninstall the patch. I had to disable virus scanners. You know, Windows Defender doesn't like me doing this demo in front of you and comes up and complains. But you can see there were a couple of things going on here. So let's go back and look at some of the things that were elements of that attack. I talked about the possibility of a URL parsing error and how that was maybe one of the first steps to the attack. And then I also talked about the need to be able to inject script across domains. And finally, we talked about how that HTML that was running that local resource was going to need to run with higher privileges and have access to objects that aren't marked safe for scripting. So this is Microsoft circa 2001, prior to the security development lifecycle. Things like this, attacks like this could have happened. And as a result, when Microsoft started trying to build security into the product, we came up with the security development lifecycle that you've heard a lot about today. And I don't want to go into excruciating detail on this slide that you've already seen before. But there are a couple of really important changes. Instead of simply designing a product and not thinking about security into the end, you can see here on this slide, we think about security and designing for security up front now. And that's an important change. Also important, when the security research community finds a vulnerability, we have an organization of people that specifically spend time listening to them and working with them. And then, instead of just kind of ignoring security as a low priority, now we actually take those vulnerabilities that people report and we use them to design and come up with new ideas about how to make more secure products. So that's kind of the way that we'll focus our discussion today. And I'm going to drill in on one of the particular tools for the security development lifecycle, and that's called threat modeling. That's the tool that we use for secure design. If I talk about the red team and the blue team, does anybody know what I'm talking about? So when I talk about the red team and the blue team, imagine the red team is the attack team, the guys looking for vulnerabilities in your system, looking for ways to break in, and the blue team is the team trying to defend the system. So when I look at this diagram on the screen that's probably faded out for you, what I see is a set of resources that are going to come under attack and a set of avenues to approach them. That means that is the playing field between the red team and the blue team. The red team is, maybe at badguys.com and going to send malicious URLs that have those encoded characters, HTML that's got garbled input, and using those vectors, that's the way that the red team's going to attack. So this is a super high level look at how a threat model might be used to identify attack vectors inside of a product. This is super high level. With IE, the only thing you could determine from this is, geez, the internet looks scary. So obviously this isn't useful for making IE or another browser safer. So really quickly, I want to show you how Internet Explorer works kind of at a component level, and then we'll tear apart one of these components to look at the threats that we saw in that mock attack. When a user types in, myspace.com into the address bar, that goes into the user interface layer, sends a request through the network requests layer, which returns a bunch of HTML and script, and then we render that in a page, and maybe we have some Flash content or some other script content that we load as well. So those are kind of the three main steps to going to the internet, bringing back a web page, and showing it to an end user. So now, when I showed you that attack, we saw there were a couple of places that we had to be compromised. There were 3 places we had to be compromised. Now let's look at this data flow diagram. This is a drill down into the page rendering layer. Let's look at the avenues of attack that had to be compromised in order for that attack to be successful. So the first thing is that we saw that maybe there was a URL parsing error. I described that through some encoding, the attacker might convince IE that this wasn't my evil myspace.com, that it was really, c:/inetpub root. So now that's a threat, that's a risk that we would want to mitigate. Okay. The other thing is that once that trick had happened, that the script was able to come back and access a page that it shouldn't have had access to. It was able to access a local resource page. And then finally, the victim page was able to run with elevated privileges and access to an object that it shouldn't have had access to, an object that was capable of writing that evil.exe file to the file system. So now let's go back and I should be clear on this diagram. I pointed out ActiveX as the threat, and we'll talk more about ActiveX later. But in the mock attack that I used, the object that I had used in that case was not a normal ActiveX control. It was a kind of a deeper level COM object that I used in the attack in order to write that file system object. But it's a similar threat. So now that we've seen those threats, with using the security development lifecycle, we were able in XPSP2 in particular to go back and engineer protections against that. So that web page running with elevated privileges that was able to access an unsafe object, that's all been locked down by the local machines on lockdown in XPSP2. And we've added a bunch of code quality improvements. So specifically, a lot of those URL parsing errors that we'd seen before went away. But that wasn't a big focus in XPSP2 compared to IE7. And then we did a lot of other things that were more prevalent to the user. So you may have seen the information bar before you download an ActiveX control or before you allow a pop-up from a particular website. And those are the things that most people are more familiar with about XPSP2. Very important changes that help protect the user and put the user in more control of their system. But those didn't necessarily fall out of these threat modeling exercises. So while we were busy with XPSP2, this thing called phishing came along. And I stole this slide from the anti-phishing working group from Peter Cassidy. He left it on my system. That'll show everyone in this audience about leaving slides on my system. I'll just use them. But it's really easy to see here that phishing is still growing. Phishing is on the rise. In particular, we know that malware is now being used to harvest end users' information and pass that along to the criminals. So it's important that we continue to invest in security. And I think that everybody in this audience, I'm not going to be saying anything controversial by saying that security is never over. Security is a journey, and it's something that we have to be committed to as an industry in order to kind of to help protect end users. So now let's go back to that threat model diagram. And we talked about some of the threats before. And we've talked about the security development lifecycle. There are a couple of principles that are pretty obvious to secure design. One of them is to reduce the attack surface of the product. So if I can reduce the number of components that are running in a system, I can reduce the complexity and therefore reduce the chance for a vulnerability potentially. So one of the examples of attack surface reduction is a feature called ActiveX opt-in. I don't see HD Moore here in this room today, but HD Moore has ran a project called Browser Fun, the month of browser bugs, and he was able to go ahead and find vulnerabilities in some ActiveX controls that were sitting around the system. But one of the things that's really clear is that if you're able to reduce the attack surface, you can actually prevent those vulnerabilities from being taken advantage of by an attacker. So that's an example of how we're making IE7 more secure through the STL. Another thing that we're doing is that we're improving the code quality of IE7. So we're rewriting important sections of the code based on the threats. So we understood, based on the threats and based on the threat model, that URL parsing is incredibly important, and that getting that right every time is incredibly important. So we rewrote the code that does URL parsing to consolidate it into one single function so that that's done consistently and that there aren't disconnects when we're evaluating things like the cross-domain boundary. And then a third principle that's going to switch us into another, we're going to switch over to another kind of data flow diagram here. A third principle is this idea of defense in depth. And John Lambert talked about defense in depth earlier today as one of the ways that Microsoft kind of adds additional protections, because we know that no matter how much security work we do, there will still be vulnerabilities in the code. So we add defense in depth in order to make exploiting those vulnerabilities more complicated for an attacker and give users an extra layer of protection. So I showed you this high-level diagram of the IE process, and I said, well, there's not much you can do here except just disconnect the internet in terms of protecting the user. But one of the things you can do is that you could potentially add a new boundary and reduce the privileges of the entire IE process. So here, what I've done is I've tried to change that data flow diagram to show you that we've taken Internet Explorer, and by coloring it orange, I mean that it's now less trusted, and we've reduced its privileges. And we've added another boundary, and that adds additional complexity in order to realize a successful attack on an end user. This diagram doesn't do the work that we've done justice. And what I want to do is I want to focus on these three features to illustrate them. I'm going to demo these three features for you. Before we move on, I'll say that these are just examples. These three features are just examples of a lot of other feature-level investments that we've made in order to make the system more robust. Again, even this more verbose slide, simply examples of things that we've done to make the system more robust, where there are tons and tons of fixes, particularly from the fuzz testing effort that we've done, that simply are never going to be kind of applauded and lauded, but really have helped make the system a great deal more robust. So now I'm going to switch over to the Windows Vista system, and you'll have to bear with me while I get it projecting again. It's always fun to come back. Okay, so looks like we're successfully projecting. So I told you I wanted to show three features that help protect the user. I want to show how we reduce the attack surface with ActiveX opt-in. I want to demonstrate something about URL parsing, and then protected mode. So I mentioned my brother, who seems to be willing to do anything for free music. Free photos aren't far away. So like all good attacks, we start in my brother's inbox. And here, when I go out to this website, the first thing I notice is an information bar that's, in this case, actually not telling me something particularly useful. But there's actually a ton going on in this page. So I'm going to click on this information bar to see that, hey, there's something going on with add-ons, and there's something going on with an international website. So let's take a look and see what this website's trying to do. So this website is using a demo ActiveX control that we built, and it's trying to write a local file into the user profile, start menu, blah, blah, blah. So we all know where this is going. This isn't a good thing. It's not a good file, and we don't want it to be dropped into that folder. Well, because of that feature ActiveX opt-in that I told you about, add-ons have been disabled by default on the system. So this ActiveX control isn't running in the page right now. And that means that we've eliminated that attack surface from the user's default system. So this attack has already failed. But let's look at a couple other things. Well, the address bar kind of looks like garbage. I don't understand what website we're actually at. If I click on this international website address flyout here, I can look, and I don't know if you can see on the monitor as well, but it says that native language address is kitosophoto.com. Imagine kitosophoto.com were a real business, like, for example, a Snapfish or a Kodak website. And imagine that an attacker was trying to make their URL look like that. Well, we added support for international domain names in IE7. We added a feature that actually adds some potential security surface area. But because we were able to consolidate the URL parsing logic in one place, we felt confident about adding that feature. And then, in addition to adding that feature, we added secure defaults for that feature. So we decided that if a website address includes a Cyrillic character from a Russian character set that's easily confused with a Latin character that we use in English, that's a potentially malicious URL. And this is a way that we can help be secure by default against attacks through international domain names. So this website's failed in two ways. It failed to run that ActiveX control and use it to attack me, and then it failed to kind of con me into thinking it was a real Kitosa Photo website. So my brother, on the other hand, shoot, he's really dedicated, and he's going to get this free stuff no matter what, because he knows that I'll be around to clean up the system, shortly, right? So let's get him to run this ActiveX control. And the information bar is still showing because of the international domain names. But the ActiveX control is now running in a page. Okay. And let's go ahead and when we click through there, that should have dropped the file into the startup folder. Let's go look in the startup folder. Well, the startup folder is empty in this case. When we saw that successful attack on XP, that mocked up attack that I showed you at first, evil.exe ended up there. Here it's empty. And what happened is that Internet Explorer is running in protected mode. And that means that Internet Explorer, the process, has been specifically configured to have access to the temporary Internet Files folder, but not necessarily to have access to the rest of the system. So that's kind of a bit of an obscure concept, and I've got another diagram here that can help kind of put this in context. So before I talk about Internet Explorer in protected mode, I want to talk about IE running as an admin. Who here runs their system as an administrator? Go ahead and admit it. I don't believe you. So if you run as an admin, then that means that processes that you run are running with your privileges. Internet Explorer's main job is to get HTML and to get images and to put them together and show them to the user. On occasion, Internet Explorer goes ahead and downloads an image, and the user wants to save it someplace. And in that case, maybe they save it into the My Documents folder. And that's a more important folder because stuff that ends up in the user's profile might potentially get reused, and we saw that startup folder that I keep trying to attack. On rare occasion, those admin rights really come in handy because the end user decides that they want to install a new extension for their browser. They want to install a new ActiveX control. They want to get Flash, they want to get QuickTime, they want to get Real. All of those are important extensions that are important to the way that we all experience the internet today. So it's important for the end user to be able to get them. So IE runs with admin rights for just that scenario. Well, if I was running with admin rights for that scenario, then IE can potentially, if it gets tipped over, drop malware into a system part of the system, an admin rights part of the system. Well, and you keep seeing me try to attack the startup folder, so we know that there's ways to kind of put some maybe less powerful attacks and less powerful malware into the startup folder. So it should be really clear that, well, maybe IE doesn't need to be running with that level of permission by default. And a secure default way for IE to run is to run with the least privilege. So with protected mode, we've configured IE so that it has access to the temporary Internet Files folder, because that's its primary job. Now, if the user wants to download a picture and save it in their My Documents folder, we still have a separate process that's able to prompt the user with the same experience the user's always seen and let the user save that into the My Documents folder. But it's not in the primary IE process. And then, again, to reduce attack surface, we've been able to separate the ActiveX control installation part of IE into yet a separate process that only runs on that rare occasion when the user is going to add one of those add-ons to their system. So now, as soon as you see this architecture, you think, well, that's going to help make the system safer. But what about that toolbar that I've been running inside of IE for so long? What about that thing, I've typed all my favorite searches into that one toolbar, and if that's, going to try to write to the registry and if that's going to fail, then my toolbar's not going to work anymore. So we built a redirector that runs inside of the IE process, and if there's a part of the system that needs to, if there's a part of the IE process that needs to write to a user rights part of the system, we're able to redirect that into the temporary Internet Files folder or an analog to that in the system registry. Now, if that is true, that the compatibility redirector is running inside of IE, well, what happened in that attack that was targeting my startup folder? Let's go back and look at my startup folder and see what really happened. Well, we saw that my normal startup folder was empty. But here, what's going on here? This is a virtualized, dynamically built fake copy of the startup folder that IE built so that that extension running inside of IE could think that it was putting a file someplace successfully. So you can see how we recreated that path to the startup folder. Now you say, well, isn't that dangerous that this file is there? Well, the user's never going to find this, and this isn't a place that's going to automatically be built to launch this file. But even if the user were able to find this, or this file somehow tried to automatically launch itself, we've added another protection in that when IE wrote it, IE wrote this file with the same permissions it had. So if this file tried to get out and do something that it wasn't able to do when it was running inside of IE, it's also going to have, it's also going to face some more obstacles in terms of the permissions that it has on it. And then one of the things that I like to show security folks, because I think we all want to be able to do this once in a while, is, hey, I want to be able to clean all the garbage out of my system. So with IE7, we've made it really easy to go ahead and delete, even some of these things that have been stored in the virtualized part of the system here. And if I go back, here you can see how I was able to clear that out. So you can start to see how this combination of attack surface reduction and code quality improvements and defense in depth helps to neutralize some of the threats that we've seen in the past. Now, we've also, I said we were going to protect the system, and we're going to try to protect the user. So let's go back to this threat model. Now I could start talking about pop-up windows attacking the user, and I could start talking about, URLs getting out of sync and interesting things like that. But I've got a bigger problem on my hands. Like I said, when I go home to visit the family, I've got John Franco, serial downloader, and he's installed whatever free music sharing app du jour he's been able to get his hands on. And as a result, well, let's just say there have been some attacks and compromises around the Franco family household. So let's go back to good old John's inbox and look at some of the attacks he might see. So believe it or not, this kid's getting married next week. It's shocking to me, and the rest of the family is now starting to think that I'm the up next. So there's some serious issues going on there. But let's look at one of the emails that John's going to get after he caches all of these wedding present checks. None of them will come from me. So he's going to get some friendly reminders from his bank. And what happened here is, of course, that was a phishing email. After John went to the phishing website, IE was running its phishing filter, and we were able to call a web service in the background. Now, it turns out that this particular site is a known phishing site that we've detected, and we've been able to populate up to a web service. So the web service sends a message back to IE and says, get the user out of there. We get the user out of there. We don't prompt them and ask them if they'd like to continue, if they think this is a fun place to be. We just get them out of there. Since this is since all of these blocks have come back as a result of the web service, we know for sure that we've been able to block about 150,000 confirmed phishing sites across the 10 million users who've downloaded IE7, and that's over the last 3 months since Beta 2 has been available. So you can see how this feature is already starting to have an impact in protecting users. Now, this isn't going to be able to stop all phishing, obviously, because if we knew about all of the phishing websites, well, we would have just, the cops would have arrested them all already. So there are going to be sites that haven't been reported and haven't been confirmed yet. And to help deal with those sites, Internet Explorer also includes heuristics that are able to detect some common patterns in phishing sites. And here, when I went to this site, the web service sent back a response saying, I don't know if this is a good site or a bad site. But IE looking at this on the client is able to detect things like, hey, it's collecting personal information, it's not using HTTPS, and it has a potentially misleading domain name. So those are some heuristics that IE may have used in this case to decide, hey, this is a suspicious website. We're still able to warn the user and help them make a better decision about sharing their information online. And maybe more exciting for the folks in this audience, if you get to one of these sites and you see this suspicious flag, you can report that this is a phishing website, and then that's going to go into a data pipeline where human graders are going to look at the site and try to publish that as a known phishing site. So the next time a novice end user goes to the site, they're going to be protected. So right about this time in my presentation, usually there are 7 hands shooting up saying, oh my God, how does this work? What the heck's going on? So despite your lack of enthusiasm for questions and raising your hands, we're going to go, oh, okay, this is a little bit out of order. We didn't show the anti-spyware integration. Well, too bad. So we did look at the phishing filter, and we're going to look at high assurance SSL in a second. and we're not going to look at card space, and we're not going to look at parental controls, but they're very cool. So back to the phishing filter. Now, IE is, like I said, going to call a web service to check on a site to see if it's a phishing site or not. But it's not going to do that for every site because, MySpace.com and Amazon.com, those are known sites that, are operating. They're fine. They're not conducting phishing scams as far as I know. So we've got a known list of good URLs and that's cached locally. On maybe 5% of navigations, an end user is going to go to a site that known list of good URLs doesn't know about yet. And in that case, if the site is trying to collect information, that's when the phishing filter is going to go and call the web service. Obviously, if we're checking a domain name against a web service, we have to be protecting the user's privacy. So there's a couple things that we're doing to protect the user's privacy. First of all, we're sending this request over HTTPS, so it's encrypted, so a third party can't intercept the request and determine what website the end user was visiting. Second, as we send the request, we try to strip out personal identifiable information. For example, anything after the query string on a domain name, we try to remove that as well. And right away, we should all start thinking, oh, well, maybe the phishing guys will try to use that as an attack. And then finally, we engineered the web service so that if if you check on a particular URL and you send your request, it's completely anonymous. We don't record the IP addresses of the clients that come and try to use the phishing filter service. And we actually had a third party come in and do an audit of that process to make sure that it does in fact not record the IP addresses of the end users who come and use the service. So that's an illustration of how the phishing filter is trying to help protect the end user's privacy. So now, another question that folks have is, well, what if my site turns out with that crazy yellow address bar and the big warning flag dropped down in front of it? I want to protect my site from having that happen. And what happens if I go and I report a website, or a bad guy reports my site as a phishing site, trying to put me out of business? So in order to help protect against kind of bad data getting into the web service, end users can report phishing sites, but they don't automatically get populated to the web service. We have a set of human graders who are going to look at the reports, and we're going to use heuristics to analyze and consolidate those reports so that we have the graders looking at the most important ones first. But if a legitimate business reports that they've been misidentified as a phishing site, then in that case what we're going to do is allow the website owner to kind of jump the line and immediately get attention from these graders so they can correct any error that exists on the web service. Then they populate their information to the web service, and obviously we can't do this on our own, and we use some important third parties to help fill out that data as well. So this explains kind of how we're going to help protect users from these known phishing sites and maybe some suspicious phishing sites. But that's going to happen for a very small set of users who end up on one of these sites. And really today, there's a bigger problem that 50% of internet users don't feel confident doing business online. And really, that's a problem for everyone, not just the folks who've had a phishing incident. So one of the things that we've done in Internet Explorer is we've worked with the other browsers and the certificate authorities on a new standard for SSL called High Assurance SSL. So here, very quickly you can see that this green address bar is intended to give the user more confidence about the site that they're visiting. What's going on here is this isn't just a regular SSL certificate. You and I could go get a regular SSL certificate, from a hosting provider like GoDaddy.com. You guys could have everybody have a site up and running with a regular SSL certificate by the end of my talk today. And it might not have any particular information about who you are. So an end user can't really feel too confident about who they're doing business with when they get, when they go to a site with a regular SSL certificate. Well, High Assurance SSL aims to correct that by setting a higher standard for these certificate authorities like VeriSign and GeoTrust and Komodo to go out and actually make contact with the people they're selling certificates to and identify that, hey, this is a real business. It's really allowed to do business in the jurisdiction that it's registered in. And by virtue of that, then VeriSign or GeoTrust or Komodo or GoDaddy is able to go ahead and say more and able to say, hey, we believe you have more reason to have confidence in the identity of this website. So a lot of folks say, well, how is this different from what the original SSL standard was supposed to be? Because really, I think a lot of people still hope and believe that an SSL certificate is kind of that level of confidence. One of the things that makes it different, along with this kind of user experience, is that at the beginning you would have seen the name of the certificate authority in the address bar of IE. So that means that the certificate authority now has their brand in the user's vision, in the user's way. And that's something that they're going to want to go ahead and elevate and protect. So now they have a great stake in the game in terms of ensuring the sanctity of these certificates. And based on that and the end user having this kind of premium experience, you can see now it's easy for an end user to make a decision about a site where they actually do want to do business in a site that they trust. There are a couple of interesting other things we've done in this area of helping the user make better decisions online. Pop-up windows before IE7, could have an address bar, maybe not. They could have a JPEG at the top of the window that looked like an address bar. Well, we know that JPEG at the top of the window could be used to fool a user into thinking that they were at a site they weren't at. So what we've done with IE7 is, every pop-up window is going to have this kind of permanent address bar added to it, and that's intended to help the end user be more confident about the site that they're visiting. So here you can imagine if this entire inner part of the page was, some other website, some other fake JPEG of another website, the user would still have this top outer address bar that they could use to help make a decision. And there's a ton of really interesting research going on in this area with the W3C and folks like Colin Jackson from Stanford, who are looking at and identifying ways that browsers can get better in terms of flagging end users about the true identity of the site they're dealing with. A feature that we're not going to talk about today, unfortunately, called CardSpace, is a project that we're working on at Microsoft, but it's also something we're working on with the open source community. And the CardSpace experience is really cool. I wish I could show it to you. What it does is it takes the user, if I go to a website and I want to type in my credentials today, if I was using CardSpace, I could go to a website and go to a secure experience that takes over my whole screen and helps me understand that I'm about to kind of give my credentials to a particular website. And it does so in a way that's really almost impossible to fake. So that's a really exciting experience. And if you have any interest in this idea of users kind of screwing up online and how we're going to try and make that safer, the CardSpace initiative is something that's really exciting, and I hope you'll come learn more about that. So now I'm going to take this back to that security development lifecycle, because I've shown you the protect the system, and I've shown you some ways that we're trying to protect the user. Security development lifecycle isn't over until IE7 ships. So now we're in kind of the final throes of shipping, and that means that we're looking for security bugs, and all of the testers inside of Microsoft have become security testers in effect. We're still using aggressive fuzz testing to try to root out vulnerabilities, and we're still engaging pen testers to help find vulnerabilities before we ship. So it's on rails, and one of the things that I can say is that watching this process at the end with IE7 is incredibly different from the process that I watched when I was a young program manager at Microsoft trying to get that fix in for the media bar. And people saying, why is that a security problem? This is a lot different. This is a different company. So I think that the security development lifecycle is helping make Internet Explorer a safer product through the protections we've added to the system. The protections we're adding to help protect the user obviously make an important difference for folks as they're on the internet today. We fully acknowledge that security is never done, that there is an ongoing, I want to say, feedback and customer connection loop that we have to make with end users and with the security community in order to continue to identify new attack vectors and to proactively address them. I want to thank you for taking the time at the end of a day, at the end of a conference, when I've competing against a swimming pool and warm weather for coming to listen to me about the things that we've done at IE. Thank you very much. Happy to take questions either out loud or up here. Go ahead. The question was, is the phishing database software open to third-party providers? And right now, what we're trying to do is figure out how to do this and make it work for IE. IE is going to have a ton of clients, and we're focusing right now on making it work for IE. We're not sure how we're going to proceed with that in the future. But the short answer is right now this is for IE specifically, and in the future you can imagine that there's an opportunity to partner with third parties who want to provide those type of protections. Anybody else? Go ahead. So the question was, if I'm submitting phishing websites and I'm completely anonymous as I do that, then how can Microsoft not get kind of fooled by somebody who's continually reporting a fake website, basically? Is that sure. Yep. So there's a very important subtlety in that anonymity that I explained during the presentation. When you use the phishing filter and you get that red address bar or you get the yellow address bar, you're anonymous to Microsoft in that case based on the way that I had the phishing filter configured here today. But if you go and on that yellow address bar dropdown, if you say, this was a phishing site and I want to report this, then there's an experience where you have to, kind of figure out one of those JPEGs images, like kind of prove that you're a real person. And then in that reporting process, you aren't anonymous in that your IP address would be logged in that process. That's different, right? That's a different way of using the product, and there's a separate kind of privacy process and policy around that. If you report a website as a phishing site, so the question, before I answer it, the question was if a site hasn't been flagged as a phishing site and you report then, do you kind of, is your IP address effectively stored? And yeah, if you report a phishing website, it's not like we're building a list of names of people who've done that, but it's not as anonymous as the average browsing around the internet case. And I think that's important. It's there's two modes of the phishing filter here, and I had two slides. I had the one mode, which is I'm browsing around the internet, I'm at a fake banking site, IE figures that out through talking to a web service and gets me out of there. In that case, there's no, my IP address is not being stored on some server at Microsoft. There's no trace that I was ever there. Now, in the other, there's another possible case where I am a vigilante and I'm going to go out and find these phishing sites and I'm going to report them all to Microsoft. And that goes into a different data pipeline. That actually does go into a data pipeline, whereas the first case, there's no data pipeline. It's kind of just a check against the list. The second case is a data pipeline where we are, able to look and say, hey, this one guy has hit us with this request, 1,000 times in the last minute. He must have figured out a way to, figure out what's in that image, right? He's got some software that's reading that image and then able to spam us, and then we can go and shut down that, like reports from that IP address or filter them out. But the thing that's really fascinating about the phishing filter in terms of the way that we do security is that it's innovative in that it adds new challenges. It adds challenges exactly what you're describing, and that's when somebody asks, well, is this going to be open to third parties? It's really up to us at this point to make sure that we can make it work for our own clients and protect our own customers first before we kind of unleash and have other partners using it as well. Okay. Any more questions? The question was, if the phishing filter is going to block a site and throw that red address bar and take the user away, is it blocking based on domain or based on the entire path? And the answer is actually both, that it's capable of blocking based on either. So you can imagine that there's a deep dark folder on a GeoCities or a MySpace site someplace that somebody has managed to pollute, and that's been reported and confirmed. And obviously you wouldn't shut down or block everybody accessing one of those important major sites, but you could block based on a particular path and then contact the GeoCities server admin or contact the MySpace server admin and work with them to take that down. Okay, any more questions? Thanks very much.